Vidhai is a non-profit initiative by the students of IITDM Kanchipuram. In this chapter, we are going to learn about carbon and its compounds. In the previous video, we've discussed about homologous series and hydrocarbons and few basics. In this video, we shall discuss about classification, nomenclature, IUPAC rules, ethanol and chemical properties and uses of ethanol. Classification based on functional group. Let us take a common example, ethane. Ethane is CH3, which is C2H6, and this can be further written as CH. If we substitute one H by OH, we get alcohol, and if this OH is substituted by an double bond O, we get aldehyde, and if this H is substituted by some other group like a methyl or an ethyl group, we get ketone, and if this ethyl or methyl group is substituted by an OH, we get carboxylic acid, and if this H in the OH is substituted by an R, that R can be a methyl or an ethyl or propyl group. In that case, we get an ester, and if this is completely substituted by an OR, that is an H in the alcohol is substituted by some other ethyl or methyl group, we get an ether. Nomenclature. The IUPAC name of any organic compound consists of three parts. If we take one word, this is the prefix, this is the root word, and this is the suffix. The prefix represents the substituent or branch present in the parent chain. Atoms or group of atoms other than hydrogen attached to the carbon of the parent chain are called substituents. Fluoro, chloro, bromo and iro represents the halo substituents. And NH2 is amino, CH3 is methyl, ethyl, and if we have CH2, CH3, it is propyl, and it goes on like for butyl, pentyl. Root word. It is the basic unit. Root word is also known as the parent word, which describes the carbon skeleton. It gives the number of carbon atoms present in the parent chain of the compound and the pattern of their arrangement. Based on the number of carbon atoms present in carbon skeleton, most of them are derived from Greek numerals. According to mathematics, we know 1 is mono, 2 is di, 3 is tri, and 4 is quad. But in chemistry, 1 is meth, 2 is eth, 3 is prop, 4 is but, and 5 is pent, 6 is hex as usual. And we are taking an example with respect to alkane. Therefore, we have them as methane, ethane, propane, and butane. Suffix. The suffix forms the end of the name. It is divided into two parts such as the primary suffix and the secondary suffix. The primary suffix comes after the root word. It represents the nature and carbon-to-carbon bonding of the parent chain. If all the bonds present between the carbon atoms of the parent chain are single, that is, if everything is unsaturated bond, we know it is alkane, then alkane gets ane as the suffix, and if there's a double bond, it gets ene as the suffix, and if there's a triple bond, it gets ine as the suffix. Ethene, ethyne, like that. And used for compounds containing double and triple bond. The secondary suffix describes the functional group of the compound. Rules for naming a compound. Identify the longest chain of carbon atoms to the parent name. Number the carbon atoms of the parent chain beginning at the closest end of the substituent or the functional group. These are called the locant numbers. If both functional group and substituent are present, then the priority will be given to the functional group. In case of alkene and alkyne, locate the double or the triple bond and use its locant number followed by a dash and a primary suffix. The carbon chain is numbered in such a way that the multiple bonds have the lowest possible locant number. If the compound contains functional group, locate it and use its locant number followed by a dash and a secondary suffix. When the primary and secondary suffix are joined, the terminal E of the primary suffix is removed. Identify the substituent and use a number followed by dash and prefix to specify its location. Let's discuss this with an example. Before that, we'll see a few common things and then we'll discuss with a question. If we are taking methanol, methane is normally CH4 and methanol is CH3OH. Therefore, one H is substituted by an OH, and we know methane is methane and alcohol gets an OL as suffix. Therefore, E should be removed and we get methanol. Similarly, for ethanol, we get ethane and OL, therefore ethanol, and ethanal, that is an aldehyde, we get ethane and Al, and E should be removed and we get ethanal. And if we see, methane and ethane does not have an ketone. Why is that so? If we take methane, it is CH4. Methane means it has only one carbon, but according to ketone, we should have a C double bond O. Therefore, there is no other carbon to bond with this. Therefore, methane cannot form a ketone. And in the case of ethanol, ethane, ethane has only two carbon. And according to ketones, ketone should have C double bond O. Here should be a carbon group and here should be a carbon group. And in that case, it becomes three carbon. Therefore, methane and ethane cannot have a ketone group. Let's take an example. Usually we'll start numbering them as 1, 2, 3, 4. But we shouldn't number them like that. Why is that so? If we see, this is a carboxylic acid functional group. Therefore, we've studied in the rules that the functional group should be given the first number. Therefore, this should be 1, 2, 3 and 4. And we see that the second position has a double bond. Therefore, the suffix should be in. Is that fine? But the carboxylic acid has a higher priority than ene. Therefore, therefore, the carboxylic acid should be given the suffix part. And here we have 4 carbons. Therefore, butane is the parent. And the second carbon has a double bond. Therefore, it will be but hyphen 2 ene for the double bond. And at the first position we have the carboxylic acid, therefore it will become 1, and carboxylic acid is oic acid, that becomes the suffix. Therefore this is the name for this compound, IUPAC name. And if we take this compound, there is 1, 2, 3, 4, 5, because this position contains a carbon and this position also contains a carbon, this position also contains a carbon. And in this case, if we are numbering like this, because this has the longest chain, we can't number 1, 2, 3, 4. That is only 4 carbon, but in this case we are getting 5 carbons. Therefore, the parent will be pentane. And we see the fourth position contains a bromine group, and bromine is a substituent. Therefore, it comes as a prefix. And then we have a double bond, and we have a double bond at the second carbon. Therefore, we have one ene, and we have methyl substituent at the third position. So it will be 4 bromo, because bromo is a substituent and it is a prefix. 3 methyl, because the third carbon contains a methyl substituent. 3 methyl pent, because the parent is pentane. Pent 2 ene, because the second position contains a double bond. And this will be the IUPAC name for this compound. Talking about ethanol. Ethanol is commonly known as alcohol. All alcoholic beverages and some cough syrups contain ethanol. Its molecular formula is C2H5OH and its parent is ethane. How do we manufacture ethanol? Ethanol is manufactured in industries by the fermentation of molasses. How is molasses prepared? If we take a sugar cane and cut all its leaves and remove its skin, and if we smash it and start boiling it, we get a thick brown liquid, and that brown liquid is known as molasses, and from that molasses, if we heat it continuously, we'll get the sugar. Molasses contains only 30% of sucrose. What is sucrose? C12H22O11 is called as sucrose, which cannot be separated by crystallization. It is converted into ethanol by the following steps. Dilution of molasses. Molasses is first diluted with water to bring down the concentration of sugar to about 8 to 10%. So now we have very concentrated molasses and we're going to dilute with water to bring it down to 8 to 10%. Addition of nitrogen sources. Molasses usually contains enough nitrogenous matter to act as a food for yeast during fermentation. What is fermentation? If we take a dosa batter or breads, we leave the batter or the dough for around 6 to 8 hours for it to rise up and ferment. That process is known as fermentation. If nitrogen content of the molasses is poor, it may be fortified by the addition of ammonium sulfate. Ammonium sulfate is NH4 taken twice SO4. Addition of yeast. The solution obtained in the above step is collected in large fermentation tanks and yeast is added to it. The mixture is kept at about 303 Kelvin for a few days. During this period, the enzyme invertase and zymase present in yeast brings about the conversion of sucrose into ethanol. So first we have sucrose. On the addition of invertase and zymase, they become glucose and fructose. And this glucose on addition with yeast forms ethanol. And this ethanol solution is called wash. Distillation of the wash. The fermented liquid contains about 15 to 18% alcohol, which is now subjected to fractional distillation. We want to purify it to get more concentrated alcohol. The main fraction drawn is an aqueous solution of ethanol, consists about 95.5% of ethanol and 4.5% of water. This is called as rectified spirit. Rectified spirit is used as a disinfectant in few places and it is mostly used in tinctures. This mixture is then refluxed over quicklime. Quicklime is calcium oxide for about 5 to 6 hours. What is reflux? If we are going to boil something, there will be a lot of vapors that is released. To avoid that vapors to escape, we are going to close them and heat. So that is known as reflux. It is going to repeat inside itself. That is reflux. And then allowed to stand. It is allowed to settle for 12 hours. On distillation of this mixture, pure alcohol of 100% is obtained and this is called as absolute alcohol. Yeast and fermentation. Yeast are single-cell microorganisms belonging to the class of fungi. The enzyme present in yeast catalyze many complex organic reactions. Fermentation is the conversion of complex organic molecule into simpler molecules, and the example is curdling of milk. To milk we add a small bit of curd to make it completely into curd. Physical properties. Ethanol is a colorless liquid having a pleasant smell and burning taste. Ethanol is alcohol. It is a volatile liquid. Its boiling point is 780 degrees Celsius, which is much higher than that of the corresponding alkane, ethane, that is 184 Kelvin. It is completely miscible in water because we know alcohol is completely miscible in water. Talking about the chemical properties. What is dehydration? When ethanol is heated with concentrated H2SO4 at 443 Kelvin, it loses a water molecule and it is dehydration. Dehydration, removal of water. So this will produce one H plus. It will have this concentrated H2SO4 will mostly produce an H plus. So according to this, it wants to remove one water molecule. So what is going to happen? It will remove this water molecule and this has lost one bond and this has lost another bond. This oxygen will take a minus charge, therefore this will get a plus, and this will take a plus sign because of which the electron will be shifted towards this carbon, therefore there is a plus and a minus. A bond will be formed and we'll get ethylene. And reaction with sodium. Ethanol reacts with sodium metal to form sodium ethoxide and hydrogen gas. This is ethanol on reacting with sodium. Sodium is in 0 state and sodium is going to go into +1 state. And this OH is in minus state is going to, this H which is in +1 state is going to go into 0 state. Therefore, reduction is taking place in hydrogen and oxidation is taking place in sodium. Therefore, this is known as an redox reaction. Both reduction and oxidation is taking place. And oxidation. What is oxidation? Oxidation in the sense removal of oxidation in the sense addition of oxygen. Ethanol is oxidized to ethanoic acid with alkaline KMnO4 or acidified K2Cr2O7. This is potassium dichromate. This is potassium permanganate. During this reaction, the orange color of potassium dichromate changes to green color, and this can be used as a test for alcohol. What is going to happen here? First, in oxidation case, if we take alcohol in 1 degree alcohol, it will change to aldehyde, which will further change to carboxylic acid. And in 2 degree alcohol, they'll change to ketone. 3 degree, no oxidation. In this case, we have to change it into an aldehyde. Therefore, this H will be removed and this OH will be removed and we'll get HCH, double bond O. And now another oxygen will act and this will form this compound. This oxygen will attack this position and we'll get carboxylic acid as the last compound, and this is the ethanoic acid, which is the final product. Talking about esterification. The reaction of an alcohol with carboxylic acid gives a compound having fruity odor. This compound is called ester and the reaction is called esterification. Here we have ethanol on reacting with acetic acid. What will happen is just like dehydration. Remove a water molecule, but OH contributed by the acid and the H contributed by the alcohol, and we'll get ethyl acetate, which is also known as ethyl ethanoate and ester. Dehydration. What is dehydration? We've discussed earlier that dehydration is removal of water. When the vapor ethanol is passed over heated copper, there we use potassium permanganate or potassium dichromate. These are stronger oxidizing agent, and oxidation changes alcohol to carboxylic acid if it is 1 degree. And in dehydration, if we are using copper, we get aldehyde as the final product. Combustion. Ethanol is a highly flammable liquid. It burns with oxygen to form carbon dioxide and water. Uses of ethanol. It is used in medical wipes as an antiseptic. Before taking some injection, the doctor used to wipe us with a wet cotton sponge dipped in spirit, and that spirit is also ethanol. It is isopropyl alcohol. As an antifreeze in automobile radiators for effectively killing microorganisms like bacteria, fungi, etc. by including in many hand sanitizers. As an antiseptic to sterilize wounds in hospital, we've already studied that rectified spirit is used in tincture, and tincture is used as an antiseptic. As in solvent for drugs, in the preparation of methylated spirit, mixture of 95% of ethanol and 5% of methanol, rectified spirit, mixture of 95.5% of ethanol and 4.5% of water, power alcohol, mixture of petrol and ethanol, and denatured spirit, ethanol mixed with pyridine. Pyridine is a benzene ring substituted with nitrogen. To enhance the flavor of food reactants, for example, vanilla extract. What is vanilla extract? We use vanilla essence while preparing cake in baking industry. A common food flavor which is made by processing vanilla beans in a solution of ethanol and water. For more videos, stay tuned. Thank you.